All right, everyone, let's wrap up our first half of Unit 2. So, we've talked about what an atom is, the subatomic particles, and what happens when we change the number of neutrons, and that's what we call an isotope. Atoms that have the same number of protons but different number of neutrons. Okay, now here is the second way that we can change an atom. We can change not the number of neutrons, but the number of electrons. Okay, so this is called an ion. Ions are not neutral because we don't have the same number of protons as we do electrons. So an ion is an atom that has gained or lost one or more electron, and so it's no longer neutrally charged. If you have a positive ion, it's called a cation, and this happens through losing negative electrons. Okay, now this is the most common mistake that my students make. They say, oh, positive charge, that means plus, so we must have gained electrons. That's not true. Electrons are negative. So if we gain electrons, we're going to get a negative charge. We need to lose those negative electrons so that we have more positive protons, and that gives us a positive charge. So cations are positive, anions are negative. And they, like I said, gained these negative electrons. So let's say we have this neutral atom, and then we gain an electron. Now, our number of protons and electrons are no longer equal. We have one more electron than we do proton, and so we have more negative electrons than protons, so my charge is negative, and that makes it an anion. Now, if instead of gaining the electron, I lost an electron, now my number of protons is greater than my number of electrons. So I have more positive charges than negative charges, which would make the overall charge positive, and that's called a cation. So loss of electrons results in a positive charge. Gaining of electron results in a negative charge. Okay, let's play with this idea a little bit. Let's do the first couple of these together. So an atom has 17 protons, 18 neutrons, and 18 electrons. What's the element? Okay, let's go to our periodic table. All right, so we have an atom that has 17 protons. We know that protons are directly correlated to the atomic number, and that tells us our element. So when we look here, I have an atomic number of 17. So my chlorine is the charge, or sorry, my chlorine is the element. Then it said, is it an ion? If so, what is the charge? Well, let's see. We have 17 protons and 18 electrons, so they're not equal to one another, so yes, it is an ion. And we have 17 positive protons, and we have 18 negative electrons. So do you see how we have one more negative charge than we do positive charge? And so because of that, we have a -1 charge. Okay. And now it wants me to write, this ion symbol. Okay. So let me make this large here. Okay, that's a C, and then L for chlorine. Okay. Here's how the ion symbol works. You take your symbol, and then in the upper right, you put your charge here. And so this would have a negative charge. Now, so here's something you're going to notice in chemistry. Often, if we have a 1, we just assume that it's there, meaning we're just going to throw the negative sign in, and whenever you see a negative, that means -1. Same for positive. If we just see a plus, then it's going to be assumed that it's +1. Okay? So if we don't have that situation, like let's jump down to this one, 5 protons, 6 neutrons, 2 electrons. We want the ion symbol for the following atom. Okay? So we have 5 protons, so that would be boron. But we have 2 electrons and 5 protons, so we have 3 more positive charges than we do negative charges. So this would have an overall charge of +3. So let me turn. Notice I've written it as 3+ and not +3. They switched those when they put them with the symbol. Okay, so this is a -1 charge, and that's a +3 charge. Now we could include the mass number and our atomic number as well over here if we wanted to. Our atomic number would be 5, and then our mass number would be protons plus neutrons would be 11. Okay. So with this in mind, let's do this example. You'll try these two on your own. Okay, so we have 20 protons and 18 electrons. Okay, 20 protons. That is calcium right there. Okay, so we have calcium, and then is it an ion? Yes, it is, because 20 protons, 18 electrons, those aren't equal. So yes. What is the charge? Let's see, we have 20 protons and 18 electrons, so we have 2 more positive charges than negative charges, so my charge is +2. And then finally, what's that symbol? Well, it'd be Ca with a 2+ up in the right-hand corner. Right. Yeah. And our last page here. Pause and review. So please take a moment now and go through these. I'm not going to answer all of them, but I will look at a few of these with you when you return. Okay, so number 1, an atom's identity is defined solely by the number of protons in its nucleus. The number of blank in the nucleus can vary, resulting in different. The number of protons in the nucleus can vary, resulting in different elements or different types of atoms. The number of blank in a neutral atom equals the number of protons. Well, the number of electrons have to equal the number of protons in a neutral atom. Blank of an element can have different number of electrons. If we have different electrons, that would be ions. Ions of an element can have different number of electrons. The mass number is equal to the number of protons plus the number of neutrons. Okay, so show how 3 isotopes of oxygen are the same and different. Well, they're all oxygen, which means that they all have an atomic number of 8. So they all have 8 protons. They're neutral, so they all have 8 electrons. It's the number of neutrons that's different. Okay. All right, so neon here has an atomic number of 10 and a mass number of 22. So my number of protons and electrons, and these are isotopes, they're all neutral, they're not ions. So I would have 10 protons and 10 electrons, because that was my atomic number. That tells me how many protons. Mass number is protons plus neutrons. So I would need 12 neutrons to get to that 22. The isotope name might be neon, and then you have your mass number of 22. Isotope name is simply written out like that. It's neon 22, and then the symbol is just the Ne-22. Okay, so you'll go through for each of those. Label the atom. We have positive protons. We have neutral neutrons. This whole thing is the nucleus. And then we have our electrons. Okay, now this last one I really liked. It says, what happens to an atom of carbon-12, remember that's our mass number, if we lose or gain protons, neutrons, or electrons? So, we have carbon-12. We know carbon has 6 protons, and if it's carbon-12, it also has to have 6 neutrons. So if we have 1 less proton, what would happen? So instead of 6 protons, we'd have 5 protons. So that would change the element, right? So we'd go from being carbon to being boron. We'd have an element change. Okay. But what if we gained 1 more proton? So we had 6, now we're going to 7, now we're nitrogen. That's also an element change. Okay. Now, what if we had 1 less neutron? So instead of 6 neutrons, we had 5 neutrons. That would change my mass. I'd still be carbon, but now I would be carbon-11 instead of carbon-12. Now, similar idea, if I gain a neutron, I still have 6 protons, so I'm still carbon, but my mass number increased, so now I'm carbon-13. Okay. What if I gained 1 more electron? So I have 6 protons, and when it's neutral, I have 6 electrons. So now I'm going to have 7 electrons to my 6, and so this would be carbon, and we would have a -1 charge. It's now an ion, right? An anion. And then I have 1 less electron. Well, that would be carbon with a plus charge. Atoms with different number of neutrons, those are isotopes. Atoms that have lost or gained electrons, those are ions. All right, guys, we've wrapped up Unit 2. So if you are struggling with any of the material, please sign up for a study session. Come talk to me about it before we take this Unit 2 exam quiz. Okay, and I'll see you all soon.